Good day, everyone. Welcome to our pre-calculus class. This moment, we are going to tackle our first topic. But before that, we are going to recall the following. Okay, the Cartesian plane. I know you are familiar with this. First, we are going to define what is fundamental theorem of analytic geometry. It says here that every point in the geometric plane can be labeled by an ordered pair, x and y of real numbers, to be called the points rectangular or Cartesian coordinates, and conversely, every ordered pair, x and y, is an element of r squared, represents a point in the plane. Next is the graph of an equation in the variables x and y is the collection, usually also called the locus of all points p, x and y, which is the ordered pair in the Cartesian plane, such that x and y satisfy the equation. And the line is the collection of all points p, x and y, that is an element of r squared, or real numbers, satisfying an equation of the form ax plus by plus c equals 0 for some fixed constant a, b, and c. Example is the linear equation where a and b are not both 0. And we have also the line slope, which is negative a over b. And given two distinct points, we have the x sub 1 and the y sub 1, which is point p, and q, we have x sub 2 and y sub 2. And we have also the slope of the segment pq. We have y sub 1 minus y sub 2 all over x sub 1 minus x sub 2 if x sub 1 is not equal to x sub 2 at undefined otherwise. And the distance between p and q is given by this formula. We have the square root of x sub 1 minus x sub 2 squared plus y sub 1 minus y sub 2 squared. That is the distance formula. And the midpoint of the segment PQ is the point whose coordinates are the averages of the coordinates of P and Q. And this is the midpoint formula. We have x sub 1 plus x sub 2 over 2 plus y sub 1 plus y sub 2 over 2. Okay, next is the cones and conics. A cone consists of two napes intersecting at the cone's vertex. The conic section or conic, the intersection of a plane with a double-naped cone. The conic sections, the hyperbola, the parabola, and the ellipse, point out that the ellipse is the more general version of the circle, and that the degenerate conics obtained when the vertex is in the intersection, either a single point, a line, or two intersecting lines. Other degenerate conics is the empty set, which is the two parallel lines. And we will be talking about hyperbola, parabola, and ellipse later. And today, we will tackle first about circle. Now, what is a circle? Circle is the locus of all points in the plane having the same fixed positive distance called the radius from a fixed point called the center. Another definition: a circle is the set of all points x and y in a plane that are equidistant from a fixed point h and k. called the center of the circle. The distance r between the center and any point x and y in the circle is the radius. So in a circle, there is a center and a radius. Now we have here the general form of a circle. We have x squared plus y squared plus dx plus ey plus f equals 0. And regarding with that illustration, the circle is drawn in a Cartesian plane. The horizontal line is the x, or the abscissa, or the domain. And the vertical line is the y, which is the ordinate or the range. And the h and k there is the center of the circle. And the r there is the radius. So, ang radius, una siya kung pila ka units from the center to the sides, so that we can form a circle. Now we have also the standard form of the equation of a circle. And this is the formula. We have x minus h squared plus y minus k squared equals r squared. And the h and the k there is the center, and the r there is the radius. So you have to take note of this standard form of the equation of a circle. We have x minus h squared plus y minus k squared equals r squared, where the h and k there is the center and the r there is the radius. Okay, kindly look at this given example. We have the standard form of a circle, and we are going to write the equation of the circle in standard form based from that given graph of a circle. As we know that the formula of the standard form of a circle is x minus h squared plus y minus k squared equals r squared. And you have to take note always that the center is the h and the k. So here, in that graph, the center or the ordered pair is -3 and 4. The center of that circle is -3 and 4. So the h is -3 and the k is +4. And how many units from the center to the side? So we will count. We have from here 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So the radius there, meaning how many, you have to count the units from the center in that given graph. So there are 5 units, so the radius is 5, and the center, which is the h and the k, is -3 and 4. And how will you make the equation of that circle? Just substitute the h and the k there, which is -3 and 4, and the r there also, which is 5 units. So our equation now is x minus -3 squared, or the same with x plus 3, because minus negative will be the same with positive. So we can have x plus 3 squared plus y minus 4, because our k there is 4, squared equals 5 squared. because our radius there is 5. There are 5 units from that center. You have to count the units to the sides of the given circle. So that is the formula for the standard form of the equation of the circle. Now we have to go to the different example. So we have to find an equation of the circle with the following conditions. So what we are going to do is to find the equation of the circle. The first one is the center is at C2 and negative 5, and the radius is 3. So given here is the center and the radius. So the center is 2 and negative 5. As we know that the center is the h and the k. So the h there is 2 and the k is negative 5. And we have the radius or the r is 3. So we have a direct application of the theorem shows that an equation of a circle is, so just substitute it directly. We have x minus 2 because the h is 2, and plus, that is x minus 2 squared plus y plus 5 squared equals 9. Okay, why it becomes y plus 5? Because y minus negative 5, because the k there is negative 5. It's the same with y plus 5 and it's squared equals 9. Why it becomes 9? Because the radius is 3. And if we are going to square 3, that is 9. 3 squared is equal to 9. 3 squared means 3 times 3. You have to multiply the base by itself. So the base is 3 and the exponent is 2. So that means 3 times 3, and that is 9. So we have now the equation of the circle. We have x minus 2 squared plus y plus 5 squared equals 9. Okay, next condition has a diameter whose endpoints are the points A, 3 and 4, and B, that is negative 3 and 12. So here, the given is only the diameter. As we recall, the diameter is that's the distance of a circle at the center, and the half of the diameter is called the radius. And we are going to find the center and the radius so that we can make an equation of a circle, because if we are going to make an equation of the circle, the very important thing there is you have the center and the radius. But here, it's only the diameter. We don't have the center yet. We don't have the diameter, the radius yet. It's the diameter. So the first thing to do is we must first find the center and the radius of this circle, because that's the very important thing if we're going to make an equation of the circle. And since A and B is a diameter, the center must be at the midpoint of AB, and the radius should be 1/2 of the distance of AB. So from the midpoint formula, the coordinates of the center should then be as follows. We have 3 minus 3 divided by 2, and 4 plus 12 divided by 2. Again, what is the midpoint formula? It was given already. The midpoint formula a while ago. We have x1 or x sub 1 plus x sub 2 divided by 2, and y sub 1 plus y sub 2 divided by 2. So we have here 3 minus 3 is 3 minus 3 is 0, divided by 2 is 0. And 4 plus 12, we have 16, divided by 2 is 8. So meanwhile, from the distance formula, we obtain the following radius. So we have here already 0 and 8 as our center. The h is 0 and the k is 8. So we have here the 1/2 of the square root of 3 plus 3 squared plus 4 minus 12 squared. So it becomes 3 plus 3 because 3 minus negative 3 is the same with 3 plus 3. As we know that at the point A, the given is 3 and 4. So the x1 there is 3 and the y1 is 4. And at point B, the x1 is negative 3 and the x sub 2 is negative 3 and the y sub 2 is 12. So if we are going to use the distance formula, we have x sub 1 minus x sub 2 squared plus y sub 1 minus y sub 2 squared. So we have 3 minus negative 3 is the same with 3 plus 3. And it will be squared. So 3 plus 3 is 6. Squared is 36 because 6 times 6 is 36. And 4 minus 12 is negative 8. And negative 8 squared is positive 64. Because negative 8 times negative 8 is positive 64. And it's divided by 2. So 36 plus 64 is 100. And the square root of 100 is 10. So 10 divided by 2 is 5. Thus, an equation of the circle given a diameter is x squared. Why x squared only? Because our h there is 0, so no need to write 0. So just write directly x squared plus y minus 8 because our k there is 8. Squared equals 25. Why is it 25? Because our r there, or the radius, is 5. And you are going to square 5, and that is 25. Because 5 squared is 25. Or 5 times 5 is 25. Now, we have also finding the standard equation of a circle. So we have the point 1 and 4 is on a circle whose center is at negative 2 and negative 3. Write the standard form of the equation of the circle. So the given is there is a point and a center. And we are going to find the radius because the radius is one of the important ingredients in making standard equation of a circle. So we have the r is, we can have x sub 2 minus x sub 1. So we have 1 minus negative 2 squared plus y sub 2 minus y sub 1. The y sub 2 is 4 and the y sub 1 is negative 3. So we have 4 minus negative 3 is 7 because 4 minus negative 3 is the same with 4 plus 3 and that is 7 squared. And y minus negative 1 is the same also with 1 minus negative 2, it's the same with 1 plus 2 and that is 3. So we have 3 squared is 9 plus 7 squared, that is 49. And 9 plus 49 is 58. So our radius here is the square root of 58. Now the equation of the circle with center h and k, the center is already given. We have negative 2 and negative 3. And we have got the value of the radius, which is square root of 58. And as we know that the standard equation of a circle is x minus h squared plus y minus k squared equals r squared. So we will just substitute the given center and the radius that we have already solved. So we have our h is -2 and our k is -3, and we have our radius, the square root of 58. So we have x minus -2 squared plus y minus -3 squared equals the square root of 58, or square root of 58 squared. As we know that x minus -2 is the same with x plus 2 squared, and y minus -3 is the same with y plus 3 squared. And the square root of 58 squared is the same with 58. So our equation of the circle with center, h and k, -2 and -3, and radius r, that is the square root of 58, is x plus 2 squared plus y plus 3 squared equals 58. Now we will go to sketching a circle. Now the given is already an equation of a circle. We have to sketch the graph of x squared plus y squared plus 10x minus 2y equals 55. So that's an equation of a circle in general form, that is not in standard form. So we first transform the equation into center radius form, which is the standard form. And we accomplish this by completing the squares. So the first thing to do is we will group those terms there at the given general form of the circle. Those the same variables we will group, and after grouping we will apply the steps in completing the squares. So we have x squared plus 10x should be at the first group plus blank, because we're going to complete it, plus y squared minus 2y plus blank equals 55. Again, how to complete the squares. This is a review of your topic in grade 9, that is completing the squares. So in completing the square, we have to get the half of the b and you square it. What is the standard form of the quadratic equation? We have ax squared plus bx plus c. So here, our b is 10, because that's the numerical coefficient of 10x. And we have to get the half of b, and we will square it. So the half of 10 is 5, and then square it. That is why we have x squared plus 10x plus 5 squared. And then at the other group, we have the y group. We have y squared minus 2y plus blank. And here, the b here is -2. So the half of -2 is -1. And you are going to square it. We have -1 squared, that is +1. And then you square. So we have x squared plus 10x plus 5 squared plus y squared minus 2y plus 1 squared equals 55. And why we have added 25 and 1 at the right side of the equation? As we know that at the equation we have the blank there, because we have not completed the squares yet. So we will apply the addition property of equality. Whatever you have added to the left side of the equation is the same number you're going to add at the right side of the equation. So 55 is at the right side of the equation. And by completing the squares at the left side of the equation, we have added 5 squared and 1 squared. So we have to add also 5 squared and 1 squared at the right side of the equation. That is why we have 55 plus 25 plus 1. Because we have added it at the left side of the equation. We have 5 squared. And 5 squared is 25 because 5 times 5 is 25. And 1 squared is also 1 because 1 times 1 is 1. And after that, we have to make a factor of that complete squares. Since that is a perfect square trinomial, the x squared plus 10x plus 25 is a perfect square trinomial. So with y squared minus 2y plus 1 squared is also a perfect square trinomial. And we can make a square of binomial for that. So the factors for that x squared plus 10x plus 25 or 5 squared is x plus 5 squared, meaning duha ka x plus 5. Those are the factors of x squared plus 10x plus 25. And that is a perfect square trinomial. We can make a square of binomial as the factor for that. And at the other group, we have y squared minus 2y plus 1 squared. The factor for that perfect square trinomial is y minus 1 squared. Why it is minus? Because the middle term of that perfect square trinomial is also minus 2y. So if we are going to find the binomial factor for that, it's also negative. So we have y minus 1 squared is equal to 81. Why is it 81? We have 55 plus 25 plus 1. And the total is 81. Now we now see that the graph is a circle. Why it is a circle? Because that's the standard form of the equation of the circle, and we can have the center, which is the h and the k, and we have also the radius there. So we will get the center, x plus 5, the h there is negative 5, and the k there is 1. And why is it that the radius is 9? Because the square root of 81 is 9. Okay, and here's the sketch of that circle. The center is at negative 5 and 1. Okay, the center is at negative 5 and 1, and the radius is 9. So you look at here, that's the center is at the second quadrant of the Cartesian plane because the x is negative 5 and the y is 1. So we have to put, or we have to plot the point tungod sa negative 5 o tungod po sa negative 1. And to form a circle, you have to count 9 units. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So tungod po sa 10, so we have at the other side 9 units also at the left side, and 9 units at the right side, and 9 units down. So we can form a circle. That's the sketch of the circle. The center is negative 5 and 1, and the radius is 9. Okay, another example is sketch the circle given by x squared minus 6x plus y squared minus 2y plus 6 equals 0. And we have to identify its center and radius so that we can sketch the circle after this. So we have to begin by writing the equation in standard form. In the third step, note that 9 and 1 are added to each side of the equation when completing the squares. So we have x squared minus 6x plus y squared minus 2y plus 6 equals 0. So we will group with those terms with the same variables. So we have x squared minus 6x plus blank plus y squared minus 2y plus blank equals negative 6, because we have to transpose the constant positive 6 at the right side, so that becomes negative 6. And y, we have 9 and 1, because the half of negative 6 is negative 3, and we will square it. Negative 3 squared is positive 9. So that is why we have already completed the square there. We have to add 9, and the half of negative 2 is also negative 1. And negative 1 squared is positive 1. And since whatever we add at the left side of the equation is the same number we will add at the right side of the equation, that's addition property of equality. So we have now completed the squares. We have x squared minus 6x plus 9, and that is a perfect square trinomial. And we have y squared minus 2y plus 1, and that is also a perfect square trinomial. And we can have the binomial factor for that. Yx minus 3 squared is the factor of x squared minus 6x plus 9, because the square root of x squared is x and the square root of 9 is 3. And it's negative because the middle term is negative 6x. So we have x minus 3 squared, and at the variable y also, we have the square root of y squared is y, and the square root of 1 is 1. Since the middle term is negative, that is negative 2y, so our sign also is negative. So that is why we have y minus 1 squared, and y is at 4, because negative 6 plus 9 is 3 plus 1 is 4. Now, we can get the center. We have the h and the k from that given standard form of the equation of the circle. So we have the h is 3, and the k is 1, and the radius is 2, because the square root of 4 is 2. So we can now plot or sketch the graph of that circle, which is the center is 3 and 1 and the radius 2. Okay, here's the sketch of the circle. At the first quadrant, we have the x is 3 and the y is 1, so we have to plot the point anang tungod nilang duha. So, muna siya ang center, and then the radius is 2, so we will count 2 units to the right and to the left and up and down. So from the center, we have 1, 2. The right side, and also at the left side, we have 1, 2. And upward, we have 1, 2. And downward, we have 1, 2 units. So we can form a circle. So that's the sketch of a circle. If the center is 3 and 1 and the radius is 2. So I hope you're clarified on how to sketch the graph of a circle. Now, we have also finding the intercepts of the circle, or how we are going to find the intercepts of the circle. So we have to find the x and y intercepts of the graph of the circle. X minus 4 squared plus y minus 2 squared equals 16. So that's an equation of a circle. That's the standard form of the equation of a circle. So to find any intercepts, so let y equals 0. So we have x minus 4 squared plus y minus 2, so we will let y 0. So we have 0 minus 2 squared equals 16. So we have x minus 4 squared equals 12. Why is it 12? Because 0 minus 2 is negative 2 squared, and negative 2 squared is positive 4. And we will combine like terms. 4 and 16 are like terms, so we have to combine them. So we will subtract 4 both sides of the equation. So we have x minus 4 squared plus 4 minus 4, so that is 0. So the remaining term there at the left side of the equation is x minus 4 squared, and 16 minus 4 is 12. That's subtraction property of equality. We subtract 4 both sides. So the remaining term at the right side of the equation is 12. And to get the value of x, we have to get the square root or extract the square root of both sides. So we have the square root of x minus 4 squared is the same with x minus 4. And we will get the square root of 12. So the positive and negative square root of 12. And to get the value of x, we have 4 plus and minus 2 square root of 3. Why 2 square root of 3? Because 12 can be factorable, that the other factor is a perfect square, and the other factor is not. So the factor of 12 is 4 times 3, and 4 has a square root, so we can simplify it. So the square root of 4 is 2, and 3 is not a perfect square, so just put it inside the radical sign. And we have also, why we have 4 here? Because we add 4 both sides. So x minus 4 plus 4 is 0. So the remaining term at the left side is already x. And we have 4 plus and minus 2 square root of 3. Again, why it becomes 2 square root of 3? Because 12 can be factored, can be simplified. The factor of 12 is 4 times 3. And 4 is a perfect square. So we can get the square root of 4. The square root of 4 is 2. And the other factor of 12 is 3. And it's not a perfect square. So just put it inside the radical sign. So we have the value of x here. 4 plus 2 square root of 3, and 4 minus 2 square root of 3. And to find any y-intercepts, let x equals 0. So if we're going to find the y-intercepts, ang atong let 0 ang x na pod. So we have 0 minus 4 squared plus y minus 2 squared equals 16. And we have 0 minus 4 is negative 4. Squared is 16. So we can have 16 plus y minus 2 squared equals 16. And 16 are constants, so we can combine them. So we will subtract 16 both sides. That's subtraction property of equality. So 16 minus 16 plus y minus 2 squared is equal to 16 minus 16 also. So we have the remaining term at the left side of the equation is y minus 2 squared. And at the right side is 0 because 16 minus 16 is 0. And we will extract the square root both sides. So the square root of y minus 2 squared is y minus 2. And the square root of 0 is also 0. And to get the value of y, we have to add to both sides. So we have y minus 2 plus 2 is 0. So we have y at the left side of the equation. And at the right side, we add 2. So 0 plus 2, and that is 2. So the value of y is equal to 2, and that's the y-intercept. So the x-intercepts are 4 plus 2 square root of 3 and 0, and 4 minus 2 square root of 3, and the y-intercepts is 0 and 2. So that is how to find the x-intercept and the y-intercept. Again, if you are going to get the x-intercept, you have to let y equals 0. And to find the y-intercept, you have to let x as 0. Now, we have also the theorem in determining when an equation yields a circle. So there are 4 conditions here. I mean, 3 conditions here. So the graph of the equation x squared plus y squared plus dx plus ey plus f is equal to 0 is the circle centered at negative 2 over 2 and negative d over 2 and negative e over 2 with the radius the square root of d squared plus e squared minus 4f over 4. So if d squared plus e squared minus 4f is greater than 0. And then the single point, negative d divided by 2 and negative e divided by 2. If d squared plus e squared minus 4f is equal to 0. So it's a single point. So the third is the empty set if d squared plus e squared minus 4f is less than 0. So in this graph of equation, if you can have like this, so just get the value of d here and de and df, and you have to substitute the given formula here. And if the d squared plus e squared minus 4f is greater than 0, so that's so. And if the d squared plus e squared minus 4f equals 0, that's a single point. And if the d squared plus e squared minus 4f is less than 0, and that's the empty set. Now we have the historical gem for the conics in antiquity. So the credit of discovering the conic sections is given to Menechmos, a student of the Greek mathematician Eudoxus. He discovered the ellipse, the parabola, and hyperbola by intersecting one native ions cone with a plane. Though during his time they were known simply as the intersections of a cone with a certain plane. Their actual names did not exist yet. It was Apollonius of Perga who pioneered in the extensive study of this and finally gave special names to the conic sections, the ellipses, the parabola, and hyperbola. And he wrote the conics, which was antiquity's unrivaled treatise on the conic sections. And for our integration of faith and learning, like circle, God's love for us is endless. It has no boundaries. No matter who we are, He loves us unconditionally. The Bible says in Jeremiah 31:3, the Lord said, I have loved you with an everlasting love. I have drawn you with unfailing kindness. So that is all about circle. I hope you learned something today.